All right. Hello and welcome to our special event this evening. My name is Jen Stucker. My pronouns are she, her, hers. I'm an associate professor of graphic design in BGSU School of Art. I am a middle-aged white woman with longish blonde hair. I am wearing a white button-up shirt with turquoise jewelry, and I have on black framed glasses. Before we begin our festivities, I'd like to read BGSU's land acknowledgement statement. The region in which Bowling Green State University and its campuses are situated inhabit the Great Black Swamp and the Lower Great Lakes region. This land is the homeland of the Wyandot, Kickapoo, Miami, Potawatomi, and Odawa, and multiple other indigenous tribal nations, present and past, who were forcibly removed to and from the area. We recognize these historical and contemporary ties in our efforts toward decolonizing history and thank the indigenous individuals and communities who have been living and working on this land from time immemorial. Tonight's speaker is our kickoff event for our alumni show titled Aligned, 40 plus years of graphic design at BGSU, which opens tonight at 6:30 p.m. and runs from October 1st to November 7th in the Willard Winkleman Gallery in the Fine Arts Center. The show includes 170 works by 82 BGSU GD alums, and we hope you can join us, and at least definitely before the November 7th closing. On behalf of the Division of Graphic Design, we'd like to thank you for joining us today to hear from our special guests. I would like to thank the School of Art and the director, Charlie Canwisher, along with my colleagues, Lori Young, Andrea Cardinal, Taylor Simone, Peter Lush, Margaret Lockwood-Lass, Lindsay Buser, and Michelle Hoke-Henningsen for their support and promotions of this talk. In our efforts to expose our students to the best in the discipline, the Design Division has had a long history of bringing in prominent speakers to BGSU, and today is another example of the best in the field. Our speaker is here for you to share her insights on today's design challenges. We hope that you will listen intently, think deeply, and at the end, ask questions. I will be moderating questions at the end. Our speaker tonight is Helen Armstrong. She's an associate professor of graphic design at North Carolina State University. She has an MA in English Literature from the University of Mississippi, an MA in publication design from the University of Baltimore, an MFA in graphic design from Maryland Institute College of Art, and her work has been recognized by Print and How magazine and included in numerous publications in the United States and the UK. At NC State, she is the founding member of the Immersive Experience Lab. She was named a University Faculty Scholar in 2018, and from 2013 to 2015, she served as co-chair of the AIGA Design Educators Community Steering Committee, striving to build up AIGA communities of students and educators, and has served on the National Board of Directors of AIGA. Ms. Armstrong has authored Graphic Design Theory, Readings from the Field, co-authored Participate, Designing with User-Generated Content, and she's also authored Digital Design Theory, Readings from the Field, which explores works by both designers and programmers, examining the two threads of discourse, design and computation, that have rapidly merged to define contemporary graphic design. Currently, she's combined her knowledge of participatory practice with computational thinking to explore the potential of intelligent interfaces, i.e. machine learning, to address the needs in individuals with disabilities. Her new book, Big Data, Big Design, Why Designers Should Care About AI, releases October 19th, and we're excited to host her on the launch of this book, and you can pre-order her book on Amazon. I first heard her speak about this work at the UCDA Education Summit in Tennessee in May 2019. And by the time she was finished, I knew I wanted to bring her here to our campus to share her work with their students and the BGSU community. So with that, please help me welcome Helen Armstrong.
Hi, everyone. I'm really happy to be here. Jen, thank you for that nice introduction. As she indicated, I'm Helen Armstrong. I'm a professor of graphic design at North Carolina State University. I'm a middle-aged white woman with blonde shoulder-length hair. I have on a blue blouse, and I'm in my office here at NC State. And my pronouns are she, her, hers. So very excited to come here and talk about my work. Okay, with that, I'll get underway. So Big data, big design, why designers should care about artificial intelligence. This is a topic that I've grown to care quite a bit about over the years. So if I ask all of you today, if you had generated data in the last 24 hours, in the last 12 hours, maybe even in the last hour, I would suspect that many of you would say yes, that you had. Maybe you entered a building with an ID. Maybe you searched for something on a computer. Maybe you used a credit card. You drove through a traffic camera. Maybe you opened your phone using your face. Maybe you spoke to an Alexa or a Google Home. Maybe you just did a Google search, right? We are all generating tremendous amounts of data every day. And this is important because machine learning enables us to derive meaning from all of this data. And machine learning needs all of this data to work. The technology will not function unless we have accessible, large quantities of data. So this is one of the reasons why we see that this technology is becoming more and more pervasive in our culture. There's another reason why this is happening as well, and this is that the processing power needed for these large algorithmic systems to function is growing. So if we look at the numbers, as of 2018, the compute, and by compute, I'm going to define that for you. Compute means innovations in chip design, network architecture, and cloud-based resources. So as of 2018, the compute was 300,000 times larger than it was in 2012. That's a big number. That's hard to wrap your head around. But we see these two forces coming together, the availability of data and the enormous increase in compute. And this is enabling the technology. So what are some examples of machine learning? We talked a little bit about examples of how individuals generate data throughout their days, throughout their lives. Let's talk about what are some examples of machine learning in practice, because this is something as well that you encounter probably on a daily basis. So examples of machine learning might be online recommendations of books, of movies. You might encounter machine learning in your email as it filters out spam. You might get an alert that says your credit card has detected fraudulent behavior, asking for you to confirm the behavior. You might have enter any kind of social media feed and realize that that feed has been personalized and individualized for you. You might search for something on Google and your search results are different from the search results from the person next to you, because those search results have been individualized to your personal search history. You might take an Uber or a Lyft, and the ETA that is given to you is powered by machine learning. So we see this technology over and over. Sometimes it's coming to the forefront of our awareness. Sometimes it's moving to the back. Okay, so what is machine learning? Why am I talking about this? Machine learning. So machine learning is simply a set of algorithms that analyze a mass of structured and unstructured data, learn from the patterns it detects, and then makes a prediction. That prediction might be whether or not an email is spam. That prediction might be reading a body of text and predicting whether the author of the text is happy or sad. Might be a prediction of the identity of a face, right? I predict that this face to the right here is my daughter, Vivian, right? The algorithms are making a prediction. This is different from traditional programming. Traditional programming requires us to input commands. So we are inputting line after line of code. Machine learning algorithms are different. We're not inputting commands. We're not adding code by hand. Instead, we're inputting data. So for example, let's say we want to train a machine learning system to differentiate between copperhead snakes and red rat snakes, which can be pretty important if you have a snake in your backyard and you're worried about it. So differentiating between copperhead snakes and red rat snakes. So in order to do this, if we were doing this through traditional programming, we would try to input every possible differentiator between these two snakes, which could be a pretty complex task. Instead, if we're building a algorithmic system, we would label tons and tons of images of copperhead snakes as copperhead snakes. We would label lots and lots of images of red rat snakes as red rat snakes, and we would feed those labeled images into the system. And then we would ask the system to build a statistical model to differentiate between the two. So the system itself is determining the features that differentiate these two types of snakes. And these are pretty narrow systems. So if I added a face of myself into this system, it would also classify me as a copperhead or a red rat snake. One of the things about machine learning systems that is powerful, that we should keep in mind as designers, is that these systems learn. They improve over time. And you may have noticed this with a system like Amazon Echo. The Amazon Echo that you are interacting with today is not the same Amazon Echo that you were interacting with a year ago, or even a week ago, or even a day ago. The system is changing and adapting over time. An example that you've probably come across yourself as you are visiting various digital interfaces is the reCAPTCHA system. So the reCAPTCHA system serves two purposes. One purpose is the purpose that we're all familiar with. It identifies whether or not a human or a bot is visiting the site. Great. But something else is happening as well. Google is using this system to train its image recognition system for its fleet of autonomous vehicles. So it's asking us, the humans, to label images for it to use. It's using us to train its system. So the system is getting better and better and better. And you can imagine how fast that's happening, how many people are encountering these reCAPTCHAs every minute. Okay, so we talked about the quantity and availability of data. We talked about the rise in compute. These systems are, something else is happening around machine learning that we should pay attention to, which is that it's getting cheaper. It's getting cheaper very quickly. And we know from technology in the past that as technology gets cheaper, it's more widely used, right? We can think back to something like electricity. So artificial light cost 400 times more in the 1800s when it was invented than it does today. When artificial lights became prevalent, whole societies, whole industries disappeared and lifestyles changed. We started to build, construct buildings, for example, with inside spaces without windows, because we could use electronic lights to light those spaces. Our industry started functioning on a 24-hour basis. So hello, night shift. So our society changed in fundamental ways when electricity became a common, inexpensive technology. We can also look to the 90s when the internet came on the scene. So the internet lowered the cost of distribution, communication, and search. And again, whole industries disappeared, new industries arose, and our society has certainly fundamentally changed since that time. We're in a similar moment right now with machine learning. Okay, so you might be asking yourself, what does this have to do? What does any of this have to do with designers? Why should we care about this technology? So I would posit to you first that we need to care about this technology because this technology needs us. The technology needs human-centered research methods. As designers, we're trained to seek a desired future or a right thing to design. Data scientists, on the other hand, are trained to seek what can accurately be determined from the data at hand. And these are very different perspectives. So for example, imagine that a designer and a data scientist is about to throw a dinner party. So the data scientist approach would be, their approach to deciding what dish to make for that party, they would think, what ingredients do I have access to? What ingredients are fresh? What ingredients are economical? How can I optimally make a dish out of these ingredients? The designer, on the other hand, would start with, who's coming to this party? Do they have any food allergies? What are their food preferences? What do I remember them liking in the past? What kind of dish would create the kind of experience that I want them to have during this event? We need both perspectives. If we don't have both perspectives, then we're going to end up with a lot of very optimal meals, but meals that nobody wants to eat and that aren't necessarily good for us. Okay, so the technology needs us, but we can also design interesting things with it. So machine learning allows us to personalize what we are making, to individualize it to a particular person. We can think of Liz Sanders' useful, usable, desirable. Now we can make things useful, usable, and desirable for a specific person in a very specific context, which opens up a lot of possibilities to us. A couple of years ago, our grad students at NC State worked with an auto parts company on a project, and the company came to us. They wanted to integrate machine learning into their retail spaces. So the students were looking at customer needs and prototyping lots of possibilities around this. One of the prototypes that they created was a predictive maintenance app. So the predictive maintenance app predicts for the customer the maintenance needs of their vehicle before that vehicle demonstrates any problems in that area based on the make, model, and year of the vehicle. We see this same kind of predictive technology and this same kind of idea playing out in the healthcare sector right now. So, and this is predictive medicine. So using the technology to predict a medical condition before the symptoms appear. And another project from NC State, another one of our grad students created a intelligent information web, and she created this with colleagues in computer science. And on the screen right now is a wireframe, an early wireframe of this system. It's kind of got pastel colors and various menu items that you can see in the wireframe. The thinking behind this project was our student found, she did research on caretakers of kids with rare diseases. And she found that if your child is diagnosed with a rare disease, the first thing you do is you do a Google search. And what happens is the information that comes back to you can be emotionally pretty horrifying, right? Your kid was just diagnosed with this disease. And what you tend to get when you do those searches are things like end of life care, things that you're not ready to deal with as a caretaker that can really harm your outlook on the whole thing. So what she did is she worked with computer science to create this intelligent system that puts all the information into these kind of intelligent buckets so that when someone with whose child has a specific condition accesses information through this site, the site will only serve up to them the information that is relevant to a particular stage of the illness that their child is experiencing. Okay, so the next example I'm going to show you is not quite so admirable. This is an example from McDonald's. So McDonald's is experimenting with an intelligent digital menu, and these digital menus look like a typical digital menu in the sense that there are a lot of menu items and they have different prices available. But what's different about these digital menus is that these menus detect a specific individual and then prioritize content and suggest complementary items in response to the individual's buying habits, but also maybe the time of day, events that are happening in the city at that particular time. So it might say, we can see that you like bacon, egg, and cheese biscuits. So we're going to offer you 3 different combo specials that involve those biscuits. And we're going to throw in a iced cappuccino because it's very hot out. So fast food is getting even faster and even more appealing. So what you're seeing in some of these examples that I'm sharing with you is this idea of anticipatory design. So the interface that a designer is creating is anticipating the human's needs before they ask for it. So there is no need for direct user input. In another project that our grad students took on, they were working with the Watson Health team at IBM. And this team was considering how might we use our AI technology, which is Watson, to lower barriers for individuals, for deaf, hard of hearing individuals and visually impaired individuals. And this particular group was working with deaf, hard of hearing users, particularly those with cochlear implants. Through their research, they found that if you have a cochlear implant and you go out to lunch with your coworkers in a crowded restaurant, or maybe you go out for coffee, those individuals are often excluded from the conversation because it's very, very difficult for them to hear in these noisy, chaotic environments, and they can't adjust the microphones on their implants on the fly in the moment. And for that reason, they are left out of some of the most important conversations that are happening at their businesses. We all know how important those social events are. So the students worked on a wearable that they prototyped, and this wearable detects the noise level, the location, the number of people, who the individual is facing to have an exchange with, and adjust the microphones to optimal settings in the moment. And an interesting part of this system is that the user can also there's a simple tap mechanism so that they can respond to the system and help train the system over time to become more and more appropriate to their needs. And in the slide that I'm showing different variations of that interface. There's sort of circular images that are transparent, that are showing different configurations of the microphone to provide a visual cue to the user of what kind of microphone setting is being employed at each moment. And then there's some other images on this slide of individuals in a restaurant using this interface. So we can think about this concept of anticipatory design as doing it for me versus doing it for myself. These are questions that the designer is thinking of. And by the way, Amazon is experimenting with this idea of anticipatory design as anticipatory shipping. So how can we anticipate the things that you want before you want them and go ahead and ship them to you before you order them? They have patents in that area, so they're thinking about that now. Grammarly is another example of an interface that we experience, or some of us have experienced, that uses this idea of do it for me or do it for myself, this anticipatory design idea. So Grammarly gets to know your style as a writer, and as you're writing, it will suggest how you might complete the sentence using your own writing style. So you don't have to write the sentence yourself completely. It's doing it for you before you request it. And you probably experienced this. Google Docs is doing this as well now. It's not as sophisticated as the Grammarly function, but same kind of idea. So an issue that is coming up, that as we designers, we're going to start working with these concepts of anticipatory design more and more as the technology begins to undergird more and more of what we're making. An issue that's going to come up for us that we need to start thinking about is de-skilling. So when we create these features and we anticipate someone's needs, we are making a choice through those features of what we want to keep and what we want to automate in those systems. What skills do we want to shore up in people, and what skills do we want to take away? And that's a pretty heavy thing to think about as a designer. A classic example of this is Google Maps. So we could ask ourselves, do we want Google Maps to get us from A to B, but while doing so, decrease our ability to navigate ourselves? Or do we want it sometimes maybe to teach us how to get there on our own? Patty Meese heads a group at MIT, the MIT Fluid Interface Group. She and her researchers, designers, think a lot about this question of de-skilling. And they're very interested in the idea of, instead of just automating away skills continually, how might we use this technology to instead strengthen innate skills that we want to keep, both while we're using the technology and when we put the technology aside. So in one particular project, they created AR glasses, and these glasses allow the user to use a technology, a technique that some of you may be familiar with, the memory palace technique, where you map items onto specific locations and sequentially as a way to remember complex things. And this is a very ancient technique, but they created a device that allows someone to do this using AR. And their idea is you use the device to build up these skills. And then when you take the device off, those skills are stronger. So making us stronger with and without the technology. So this question of de-skilling and what do we automate and what do we keep, and what, when as designers, what's our role in those choices, is really important. Another thing for us to think about as designers is that machine learning is also changing how humans relate to machines or computers. And we can ask ourselves, how might this technology affect what we design? How do these changing relationships affect the things that we're designing and the issues that we're thinking about as we design them? So two technologies that I want to talk about. One is that I want to bring to your attention. One is natural language processing and one is image recognition. These are two technologies made possible by machine learning that have particularly high impact on our relationships to computers, to machines. Natural language processing is the ability of a machine to read, understand, and produce language. Image recognition is the ability of a machine to both recognize and understand and analyze images. Image recognition is a pretty big topic. I'm going to focus on natural language processing today. So over thousands of years, we have evolved to expect anything with a human voice to be a human. We have been programmed in this way. This is on the screen is a quote from Sherry Turkle, who's a theorist. And the quote is, "Machines with voices have particular power to make us feel understood." So two researchers, Clifford Nass and Scott Brave, wrote a really interesting book called Wired for Speech. And in this book, they share study after study in which they were trying to find out if we would bring the same bias, the same cultural baggage to conversational interactions that are synthetic as we do when we're talking to another human being. And what they found is, even when we know that it is an artificial voice, when it is very overtly a synthetic voice, we still bring the same attitudes and biases to the exchange that we do with other humans. And it is very, very difficult for us to suppress those responses. This is very important. because we are beginning to design experiences, interfaces in which conversation is playing a very important role. This kind of, whether we're doing it through text or through voice, these conversational exchanges are beginning to become our very natural way to communicate with machines. And so we need to understand the implications of what we're working with here. In 2019, FaceBot's Woebot, which is a kind of therapy chatbot, was receiving 2 million conversations a week. Amazon had sold 100 million Alexa devices, and that number has gone way up now. In 2020, hundreds of thousands of people were each sending around 70 messages a day to Replika. Replika is a personal AI companion that learns your personality style and sort of mimics it back to you in the form of a companion. Microsoft Show Ice, which is a popular social chat bot, has 660 million users, primarily in China. So we can begin to see how these technologies are influencing our society. So I'm going to talk about a little project that this was a study that another one of our grad students did. In this study, she created this little kind of lovable character called Bebop, and Bebop appears on the screen that you're seeing in a series of different screens. Bebop is this little green and red, very endearing looking robot creature. So in this study, if an individual interacts with Bebop in an inappropriate way, so if it asks you a question, for example, that's phrased in a, if you ask the bot a question that is phrased in a way that the bot cannot understand, the bot is hurt. So in the images before you, you can see that the bot might, for example, have a black eye, or the bot's arm might fall off, or the bot might start to bleed. And the images that she created are kind of contrasting this sort of graphic experience with this cute little creature. The idea here is that the bot is manipulating the human. The bot is using the human's emotions to manipulate them into interacting with the bot the way it wants to be interacted with. So playing with the potential for manipulation that our associations with language bring to these kinds of experiences. So another quote by theorist Sherry Turkle, who has a wonderful book called Reclaiming Conversation, where she's thinking about some of these issues. Even as we treat machines as if they were almost human, we develop habits that have us treating human beings as almost machines. So we're thinking here about not only how our interchanges with machines are changing our relationships to machines, but also how they might be changing our relationships to one another. But we can't ignore emotions. We can't try to sidestep these complex emotional issues, because here's the thing. We are social emotional creatures. This is how we connect to one another. This is how we communicate to one another. So if we truly want to be able to collaborate with machines, if we want to be able to connect with them in new ways, we've got to build social emotional intelligence into these things that we're creating. AI researcher Subaru Kamapati has spoken on this topic. And this is one of his quotes. If we do not focus on creating machines with an adroit social emotional intelligence, we will end up with computers that don't understand us and that don't need us. So we can't sidestep this issue. We've got to take it on. In 1997, Microsoft released a character called Clippy. It was kind of a little paperclip with eyes and eyebrows. Everyone hated Clippy. They hated Clippy because the social emotional responses of Clippy were just off. He was always kind of smug. He was way too peppy, and he annoyed people. So getting these social emotional responses right is tricky. When you get them wrong, they're very, very annoying, but they're important. We have to think about them in the work that we create. Design and Technology Studio Telart has been working on this question recently in collaboration with Toyota. So their advanced design team have created a user experience for an emotionally intelligent autonomous vehicle. So in the images on this screen, the cars have room for language to appear, so words can appear. This is sort of like a futuristic car, but it's also very, has a lot of emotional attributes through projection, through color, and through movement inside the vehicle. So they're really trying to explore the potential for creating emotional connections between intelligent agents, and the car itself is an intelligent agent here, and humans, and thinking about a lot of the pitfalls we need to deal with in those instances. Okay, we've talked about opportunities around machine learning that designers can take on. We can think about anticipatory design. We can think about this notion of both de-skilling and shoring up human skills. And in fact, in that way, we're really thinking sometimes about what it means to be human. We're also thinking about how our relationships to machines are changing and what role we play in creating interfaces that use language in those kinds, and emotion in those kinds of relationships. Now I'm going to talk a little bit about things that we should really worry about and be critical of in this technology in the work that we produce. So first I'm going to ask the question of who or what gets left out by these systems. MIT researcher Joy Buolamwini has created an organization called the Algorithmic Justice League. And she created this organization to fight what she phrased the coded gaze, to mitigate the abuse of facial analysis technology. This organization came from a project that she did while at MIT. And this project was with Timnit Gebru. You may have heard that name in the press recently. I'd say maybe it's a month ago, not long ago, she was fired by Google for bringing attention to bias, for a research paper that brought attention to bias in their system and was very controversial. Anyway, in this study that she did with Joy, they were looking at gender classification via facial analysis. And they did research on a variety of influential companies, and they found that in all the companies that they looked at, their facial analysis systems performed the worst on darker skinned female subjects. So the difference between males and females was pretty drastic in terms of inaccuracy for female subjects, but even worse on darker skinned female subjects. So thinking about who these systems are leaving out and being critical of the systems and asking questions around the systems we're putting into use. Shoshana Magnett wrote a really interesting book called When Biometrics Fail. And she was looking at this same question from a different perspective. So she was looking at biometric identification and bodies. She was thinking about, for example, how these systems might be excluding atypical bodies. So if you have certain skin conditions, fingerprint analysis does not work for you. If you don't have hands, hand geometry is not effective. There are many eye conditions that make iris scanning inaccurate. If you have an atypical voice or you have an atypical facial structure, these identification methods also do not work on you. Researcher Meredith Whitaker at the AI Now Institute in NYU has also thought about this issue. She asked, what standards of normal and ability are produced and enforced by specific AI systems? And what are the costs of being understood as an outlier? So if you are not meeting the standards that these systems have determined for identification, you in essence are invisible. And you're not only invisible, but these standards are being codified through the systems that we're putting into place. AI ethicist Raman Chowdhury, who has wonderful lectures out there on this topic. If you grow interested in them, I would encourage you to look for her. She talks a lot about these issues in a way that designers can really respond to. So one of the points that she brings up is that these systems these are statistical systems. They're never 100% accurate, and they're models. You can think of them like a model car is not the same thing as a real car. It's a model car. And these models have many limitations in a similar way. So she speaks about the need to highlight to the user the uncertainty of these systems. So when we get the prediction that these systems produce, and I am going to add that the predictions can have huge ramifications on people's lives, because the prediction might be whether or not you are a trustworthy person to receive a loan. The prediction might be whether or not you'll receive bail or not receive bail. The prediction might be whether or not your resume goes to the next pile or is cast out of a hiring system. And take a minute to talk about that, because AI systems have become much more common as screening practices for hiring over the last year and a half. So if you are a student and you're going out on the job market, you might find yourself, well, first your resume may very easily be scanned by one of these systems, and you won't know why you were rejected, how it puts you in the yes bucket or the no bucket. Or you might even be interviewed by an AI. That's also becoming common. Okay, but what I'm talking about here is this idea of certainty or uncertainty, that you're either put in one bucket or you're put in another bucket, the yes bucket or the no bucket. And you often have no sense of why you were placed in one of those buckets. The other things a human often has no sense of is if they fell kind of in the middle. And a lot of us do fall in the middle. This is the uncertainty that Chowdhury was talking about. And being able to convey to people not just this yes or no answer, but all the gray area in between, so that they understand how the system is functioning and they can respond to it. They can also hold systems accountable. So one thing that I see designers involved in right now that I think is really exciting is helping humans understand how these decisions and predictions are made by systems. So helping to design more transparent systems and interactions. And this is a way of getting into this black box that you hear about, the system that we cannot see the inner workings of. So designers at Google PAIR, and that stands for Google People and AI Research, have done a lot of really interesting visualizations around this. So the visualization on the screen right now has multiple colors. It's a pretty complex matrix with different features like occupation, education, listed across the top. These sorts of interactions allow someone to change those features out and then experiment with all of the features that are contributing to how these algorithmic decisions are being made. So just a way of visualizing the process so you can get under the hood. Stephanie Yee and Tony Chu, the founders of R2D3. Stephanie is a data scientist. Tony is a UX UI designer. They created a really beautiful narrative interactive experience that they call a visual introduction to machine learning that allows non-experts to move through the decision-making process of an algorithmic system and understand how that process is being made. And on the screen right now are various, it's sort of a tree diagram with some blue and green circles, and that tree diagram is demonstrating all of the different moments in which decisions are being made by the system. So designers are using visualization to communicate these complex systems to people, which can have an incredible impact on how people interact with them. Sarah Gold is a designer for a studio called IF, and she has done a lot of work around interaction patterns and making systems more transparent or explainable. So this is a project that she did with a commercial drone company in which she was thinking about how do we express to a user in the moment what the criteria that are being used to make these predictions in these systems. So for this company, their customers were very unhappy because they didn't understand how insurance rates were set for different trips that they wanted to do with their drone. So Sarah experimented a lot with creating simple interfaces that would pop up and explain to people what kind of features were being used to come up with those rates. Designers are also getting out there and advocating for people and educating people. So a wonderful artist and data expert, Mimi Onioa and Diana Nucera, aka Mother Cyborg, created a wonderful zine that they took out to their community in Detroit and paired with a series of community workshops. The zine is very friendly and accessible, and they used it to help people understand the technology. And their goal was to give people the agency to contribute to a more equitable technological future. So designers are getting out there educating people as well. And this zine is a free download. It's a great, it's a really interesting piece. We also need to protect people's data privacy. Often the data that we talked about at the beginning of this discussion is being extracted without dialogue or consent. And designers are often a part of that. So I'm sure some of you have encountered dark interaction patterns. So dark patterns are interaction patterns that intentionally trick people. So maybe you've tried to unsubscribe to something, or you've tried to opt out of data sharing, but it hasn't seemed to work. Well, it probably didn't work because you didn't click on the thing that you thought you clicked on, because the pattern had purposely been designed to trick you. So as designers, we're going to come to moments in our lives where we're thinking about, are we designing interactions to confuse people? Are we designing interactions to elucidate their rights? And we are responsible for that. Sarah Gold, who I mentioned earlier, who runs the studio IF, she has created a whole collection of interaction design patterns to help creative teams address ethical issues around collecting and using people's data. And what you're seeing on the screen right now are kind of simplified illustrations of some of those interactions in patterns. For example, pop-ups that come in the moment that you need them with a simple explanation rather than some kind of long disclosure that that's not really designed for anyone to read. Designers are also prototyping things like Kagi, the personal privacy advocate. This is sort of using AI to combat AI. So it is a virtual agent that gets to know your preferences over time, your privacy preferences, and goes out for you and navigates all the data privacy practices and advocates for you when you interact with digital systems. So to conclude my talk today, we as designers can be complicit. We can let machine learning prey on those in our society that it already victimizes. And we can let machine learning amplify the biases that already exist, or we can use the technology as a mechanism for equity and justice. I would encourage everyone not to let this technology intimidate you. The skills and vision of designers are really sorely needed in this area, and there's so much potential for impact here that we can have. And if you're interested in this topic, Jen mentioned I do have a book that's coming out in October, and I dig into some of these, more into some of these issues. So, if you're interested, check it out. I think that we have, as the things that we create reach more and more people. When I think back over my career, things that I created early in my career had such a small window of impact compared to the things that designers are creating today. And I think the potential there is just amazing. Thank you.
Fantastic. I knew for sure this was going to be amazing, and it was. So thank you on so many levels. We have a question in the Q&A, and it's by Todd Calloway, and it says, AI has created a polarized political system in this country by providing news that reflects singular perspectives to individuals. How do we guard against those people and corporations who use AI for evil doing? Even worse, how do we guard against wrapping ourselves in our own reality when AI is feeding the beast?
So I think the first thing we can do is educate ourselves around the technology, because if we don't know what's happening, we can't fight it, right? So first of all, we need to educate ourselves. And then this goes back to what I was talking about transparency and helping people who are interacting with these systems understand when they're being manipulated. And we as designers can play a role in that, because we have played a big role in hiding that it's happening. Right? All of the, if you're working on a social media feed, you're creating that interface that hides that manipulation behind what people are seeing. It doesn't have to be hidden. We can open those systems up so that people can call them, can call them to justice, so to speak.
Great. Can you talk a little bit about the concept of a digital twin, because I'm sure you've come across that in your research. Can you share with everybody like what a digital twin is? You alluded to some of it earlier, I think, and so I was hoping maybe you could elaborate on that.
Do you mean when I was talking about replica, for example,
yeah,
or the idea of do you mean the idea of a kind of representative of you that goes out there and represents you in the world?
Yeah, I don't know if you've heard a little bit about that.
So let's see, that's a tough one, Jen. I think it's an interesting concept. I think that, and yeah, the concept is that so right now we kind of have a digital twin already, because so much of our presence lives in a digital space and people interact with that digital presence rather than our physical self. So that's like kind of an early hint toward that. But there has been some speculation that eventually we'll have a kind of avatar that's intelligent, that will understand us, and that will go out and, we can send it to a meeting, or we can have it go out and advocate for us somewhere. I think it's a really interesting idea. I think it gets to this, I think concepts like that really get to the tension between privacy and manipulation, and for us to really think about who owns that avatar. I mean, it gets really pretty complicated, right? Like if the data that the avatar is using to understand you is somehow owned by you at the device level and protected, then that's one thing. But if there's a company creating those avatars that has access to all of that data, then obviously that's like hugely problematic, right? So I think that's an interesting question, because it sort of gets to that tension that we're experiencing right now between the ability to do some amazing things, but what are we going to have to give up in order to do those with this the current structure of this technology and the lack of legislation and restriction around it? Absolutely.
No, I could go on, but I want to make sure we get to another question someone's asked. So this is from Benji. It says, can we open up these systems? Can we open these systems up, though, in a world where capitalism has subverted agency and we truly able to be entrepreneurs at these corporations? Or is the only method for opening them up to create pathways for transparency outside of them?
That is a great question. I think it's a tough one. I think you're going to have to, this is Benji. I think you're going to have to, you can be one of the people who answers that question, right? I don't know. I think, I think that we have to, try. I think we can have a very pessimistic attitude and kind of say, we'll never escape this, so why even try? But I think if we have that kind of attitude, then we are completely complicit in what's happening. But I think the heart of your question is really, can we do it through these corporations, or do we have to sidestep them? And I think that's what we're all going to have to figure out in coming years. And I don't think we're going to know the answer to that till we try. The Timnit guru, when she was fired from Google, that was a pretty depressing sign that I don't think the corporations are going to police themselves, or the big tech companies. I think some of it's going to have to come from outside for sure.
Plus it being so intimidating, right? The technology to so many people being afraid to ask those questions or the authority. This other question comes from Andrea, my colleague. She's curious about the predictive maintenance can be used for subversive justice found means, predictive maintenance for democracy, a community. So could you elaborate on that?
So that's a really interesting question. Yes. And I think that gets to this idea of manipulation, that the huge potential for manipulation that's inherent in this technology as well. So to your point, if I'm understanding this, if I'm understanding what you're asking, is once you start to predict something before it happens, then you can also take action against it before it happens. So that is there's a lot of potential for repression, right? You could repress someone before they even take action. And this kind of goes back to, everything seems to go back to Minority Report. This kind of goes back to that, like taking action before someone even does something. So it's definitely there's a lot of negative connotations to that idea that we have to deal with. None of these questions they're all very heavy questions for us to take on.
Well, I'm really glad that you are, bringing so much of this to our attention, because these are things as designers we should be very cognizant of and asking now versus asking after the fact. So that's great. My next question is from Anna. She's one of our students here. Do you think it will ever be possible to create AI that doesn't exclude people in a way that doesn't make atypical bodies or conditions outliers? So back to that, I guess, normal, atypical that you were speaking of earlier.
I think that these systems, as machine learning currently functions, it's never going to be 100% accurate. First, there's that. It's not truth, right? It's a prediction. So that's important to keep in mind. I think I am optimistic that these systems can be much better than they are. I think that there's a growing awareness of all the people that are being left out of these systems. And I'm very optimistic about our ability to improve them. I think that someone will always be left out, but I don't think that means that we don't try to, because someone will always be left out because these systems were programmed by people, and we live in a biased society, and it's never going to be completely free of bias. But what we can do is bring bias to the surface and recognize it and deal with it and work to continually improve these systems. I got interested in this technology because I have a daughter with disabilities, and I was very interested in how these systems might respond to her very individual needs in a way that is not met at all by current technology. So I think it's important for us to recognize how many people are being left out currently, and look at the potential for changing that situation through the technology while recognizing all the problems that the technology also causes. I mean, it's always this sort of two-sided thing, right? Like this can do terrible things, but it can also do really great things. And so we're always walking this kind of knife edge between the two.
Right. When you're talking about de-skilling, I've been wondering about where designers and this is probably a good conversation for all these designers that are on the call, where AI is going to start designing for designers, that it will aggregate all the great, Graphies posters and this poster competition, and then go, here's the formula for hierarchy and contrast and balance and rhythm and texture. And so, do you foresee something like that? What opportunity might that afford to the kinds of other work that designers might do? Is that sort of what you see as a potential here?
So that's an interesting question. I think that the potential here is that we can collaborate with machines to create much more complex solutions to things first. So we can sort of stand on the shoulders of the technology and work with the technology to take on some of these really hard problems that we have in society that are honestly too complex for us to do take on without the technology. So I think there's, and we can think of that like with Illustrator or InDesign. In my lifetime, we can create much more complex things, even with just that simple software, than we could by hand. So we're already seeing an increase in complexity in our work. And I think we're going to see that change exponentially with this technology. I think we're going to also see with the technology that we'll be designing using more natural gesture and conversational, right? We'll be using language, make the sky blue, make the sky light, this whole like clicking and tapping thing. I think that is definitely going to go out the window, and we'll be able to use much more natural exchanges in the making. So that's going to change what we make to some degree, because how we make changes what we make. There's been a lot of interesting stuff with GANs lately, to the point you're making, Jen, about programming parameters, and then the parameters allow the system to create endless permutations of something and creating imagery and composition in that way. That's an idea that's been around for a really long time, and we're definitely seeing that kind of come into play. So I do think designers will play a bit more of a curator, editor role, where we still have to understand good design, but we'll be tweaking parameters to get there maybe. But we still have to understand it when we experience it, right? So we still have to have a lot of knowledge around form. And it may be that there are things that are going to evolve around form that we can't foresee now too, because that sort of GANs, like creating endless variations, which are super interesting, variations that perhaps a human wouldn't have come up with. That there may be a next level to that we're not even thinking of right now, that I think could be super interesting.
Yes, I think too, when you talked about the emotions, right? So we know that certain pieces make us, feel joy or sorrow. So how that might work into that space. So we have one more question. We'll let this be the last question. And it is a long one, but it's a great one from one of our students, Connor. It says, for people trying to do UI, UX design, it seems like companies push heavily for addictive design. For example, platforms like TikTok that predicts and take advantage of emotions and socioeconomic status to keep the user retention rates high. How do we maintain a decent living in the tech industry as ethical designers, even though it seems as if we are not welcome? Do we push small ethical design changes within companies or only design for companies that align with our design ethics? Great question, Connor.
That is a great question. So I've been interviewing a lot of our alums lately to understand what's happening in the industry. I actually interviewed 4 today. Wow. I'm like doing them like just because I want to know, I always want to know what's happening with their experiences after they get out of school. And one of the things that's coming up, I would say most of them are doing the more incremental changes inside of companies, but I have gotten from them that the companies that they're working for are more interested in what they have to say around ethics than they have been in, maybe 6-7 years ago. So I do think there's a growing awareness that that these companies have to start taking ethics seriously, because they're being called into question by the public. So I do think there's some optimism there around the kind of change you can enact from within a company. Certainly, it's also great to go a different path too and find the companies that you certainly don't want to work for a company that you have no faith in, right? I mean, that's pretty depressing. But there are a lot of companies that are kind of in between, right? They're not like, so I think you're going to have to find your own path on that, but I do think there is reason to hope that ethics are moving to the forefront in a way that that we really need, and that has not been the case in the past, that people are being heard more in recent years, and even like the last 2 years.
Yeah. And Connor, everything she said, and I would say always push for small ethical design changes whenever possible. All right. Well, thank you so much for your time this evening. We really appreciate it. I know we're going to connect again with a couple classroom situations, but this has been wonderful. We wish you the best of the luck on the sale of your book. I've already ordered my copy. I can't wait to receive it. And thank you very much. This was wonderful. So have a great weekend. Please, everyone else on the call, if you're available, come check out the opening for the show this evening in about 24 minutes.
Thank you. Thanks for having me. I hope your opening is fantastic.
Thank you. Have a great one.